Hey everyone, welcome to our lesson on transforming the graphs of log functions. We're going to take a look at the formula for a log function and where those pieces that will cause transformations will be located. So if you take a look here at our formula for a log function, a translated function that has had changes applied, it will look like this. F of x equals a some number times log of base b, which is also some number base, times x minus h plus k. And you need to know what these pieces represent and what changes are happening. So let's take a look here. The first thing you come to is the a out in front of the log term. And when you see a number there may not be a number there, but if you see one there, it's going to cause our stretches, shrinks, and or reflections. You're going to know which one is happening because you're going to be on the lookout for what kind of number you see. If you see a whole number, a large whole number, that's going to cause some type of stretch. If you see a fraction that is less than 1, that's going to cause a shrink. And then if it happens to be a negative number, that's going to cause your graph to reflect and move over the x-axis. All right, the next thing you're going to come to is the h. Let's look up here. So h causes our horizontal translations. So we are moving left or right on those. If you see that it is a value that's subtracted, it's actually going to move the picture to the right. And if you see that a number's been added inside there in the parentheses, it's moving it left. The same amount of units as the number that you see. All right, the last thing out at the end is the k. K is what causes our vertical translation, so we're moving up or down with that, and it's going to be up or down the number of units of the amount you see. So if we're adding 5, we'll move the graph up 5 units there. Okay, so we'll take a look at functions and we'll see if we can identify what's going to happen on the graph. So f of x equals 5 times log base 3 of x minus 4 plus 1. So remember the types of translations we talked about and other transformations. First thing I notice is this 5 out front. It is a whole number, so and it's bigger than 1. That is going to cause a stretch to our graph. So we have a stretch, which just means pulling it more towards the y direction. Okay, and then the next thing we see is an x minus 4 inside the parentheses there, and remember subtracting a value is going to move it right, that amount of units, so this picture will be moved right 4 units from the parent graph. Out at the end I'm seeing a plus 1, and remember that's our vertical movements, so adding an amount out there moves it up, so the picture will also be moved up 1 unit. Alright, so if you remember the parent graph of log functions, we're just going to get a general picture here. Something like that. The new picture, I'm not testing numbers. I don't know exactly where it will be, but I do know that these things are happening. So the new picture should look something like this when we're finished. We know it's going to have a stretch, so that's going to pull it up a little bit. It's going to be moved right 4 and up 1. So wherever it started, we don't know where it started, we have to test values for that, but wherever it started, it's going to have those movements and that stretch applied. All right. So you just always want to have that in your mind when you go graph. You want to make sure that it does match the things that you saw in the function. Okay. Next function, let's take a look at a different one. F of x equals negative 1/2 times log of x plus 1 minus 2. What do we see this time? First thing I'm noticing is that negative out front, and I know that's going to cause a reflection. Okay, it's attached to a 1/2, which is a fraction less than 1, and we know that's going to shrink our picture, pull it more towards the x-axis, kind of flatten it out. We see, that was our 1/2, we see a plus 1 here, which is going to move us left that amount of units. So left 1 unit. And we've got a minus 2 at the end, which is telling us to move down 2 units. All right. So we're going to go to the grid. And we're going to take a look at just a general picture of the parent function and the new picture of our function on the previous slide, what that should look like. All right, so you will need a calculator. You will need a graphing calculator to graph this picture and check the table for coordinate values where your picture will be located. Or you will need a calculator that has the log capability for you to type that operation in and test x values, okay, to get your points. So either way, whichever one you're working on, when you test a 1, you're going to get a matching value of 0 on the parent graph. So this is just the starting point for that parent graph. F of x equals log of x, okay, the basic picture that hasn't been moved. So when you put a 1 in there, you're going to get a 0 to match. So if I plot that, 1 zeros here, and you can test other values or you can look at your table and you're going to get the general picture for the log function that looks something like this, okay? Remember, our new function, we can type that in and graph that as well, or we can move it according to the transformations that we saw. Our new one should have been reflected a little bit more flat, so it's shrinking towards the x-axis. Left 1 unit and down 2 units is the main thing. We want to move that value of 1, 0, left 1 and down 2. Okay, so let's go to our grid. All right, so we're going to move this point left 1 and down 2, which will put us at 0, negative 2. All right, remember it was reflected, so it's going to need to flip over the x-axis, and it's going to need to be a little more flattened than our original picture. So if we have our graphing calculator, we can get a very good picture here. If we don't, if we're using the log function, we can still get a good picture by testing many values and plotting the actual points that this will go through. But this is the basic shape of what you're going to see. Still has a slight curve to it, but I just want to show you that it would be a little more flat than the parent graph. Okay, and this concludes our lesson on transforming the graphs of log functions.